All right. To start off, for those new to Squirro, a few words of introduction. We provide a proven enterprise AI platform designed to help complex organizations manage unstructured content and accelerate growth. And rather than forcing you to build everything from scratch, we offer a secure, auditable, and fully permission-aware infrastructure. Our platform, which can be deployed on premises or on a VPC, it respects your existing enterprise access controls, and it gives you a deployment that your security teams can easily sign off on. Now, a major milestone at Squirro was the acquisition of Synaptica, which brought decades of experience in taxonomy, ontology, and knowledge graph engineering into our platform ecosystem. And you can think of this as a balance basically between two worlds. On the left, you have the probabilistic strength of Squirro's enterprise search and GenAI framework. On the right, you have the deterministic certainty of Synaptica's knowledge graphs and semantic layers. And by aligning the more fluid language models with explicit human-governed taxonomies, you can basically ground the AI search boundaries and prevent the predictability issues that are very common in standard RAG setups. Of course, at the executive level, the ultimate metric for any deployment is always time to value. And Squirro, so it bypasses long development cycles by focusing on more or less ready-to-go use cases that significantly lower your entry risk, typically yielding a return on investment in less than 10 months. And we deliver this across four core business domains. So whether it's optimizing resolution speed at a global telecommunications operator, ensuring regulatory compliance at a tier one central bank, or scaling knowledge management for a global manufacturer, the results are always the same. We drive quality and speed up, and we force operational risks and costs down. What unites our customers, whether they're central banks or financial institutions or global manufacturers, is that they all basically operate in environments where good enough simply isn't an option. Now, to break down how an enterprise can turn a legacy taxonomy asset into a scalable engine for production AI, we're joined by two experts who look at this from both sides of the architecture. So first, I'd like to welcome Melinda Geist. Melinda is a veteran taxonomy practitioner who spent decades building up taxonomy and ontology programs inside global tech giants. And she knows exactly what happens when manual classification hits the wall of enterprise scale, and also how to successfully inject AI into that workflow without losing governance. So welcome, Melinda.
Thank you.
And we're also joined by Panos Mitsias. Panos is our semantic graph solution specialist here at Squirro with over 12 years of experience in semantics and knowledge engineering. Panos is the architect behind how we design taxonomy and LLM integrations using the Squirrel classifier. So it's great to have you here, Panos.
Hi, thank you, Jan. Thank you. Hi,
Um,
everyone.
we have quite a packed session ahead of us. Here's a brief roadmap for today. So in just a moment, Melinda will take the floor to share a case study on what the classification gap looks like from a first-person practitioner's perspective, mapping out the true payoff of automated term extraction, which we'll familiarize ourselves with in just a minute. And then from there, Panos will dive more into the technical scaffolding, and he'll show us exactly how to serialize a taxonomy for an LLM, how to build a human-in-the-loop workflow that keeps the taxonomist in control. And after that, we'll bring them both together for a fireside chat before finally opening the floor to you for a Q&A session. So just a quick housekeeping note before we kick off. The session is being recorded. We'll send you the full recording and the presentation slides by email in the coming days. And if you have any questions throughout the presentation, just feel free to type them into the Q&A window, which you can find in the menu bar at the bottom of your screen. We've reserved around 15 minutes to discuss these questions live with our experts. And with that, I guess we're ready to dive into the reality on the ground. Melinda, the floor is all yours.
Okay, thank you, Jan, and thank you everyone for joining us today.
Um,
Before I
ap-
joined,
Apologies, Melinda. We cannot see the slides, Jan.
Oh, really?
oh, I'm sorry.
I'll share
Yes,
them.
I thought it was just me.
Can you see them now?
Great. Yes.
Yes.
Oh, okay, I'm sorry about that.
All right, thank you. Well, before I joined Squirrel, I spent many years at a global technology company. And for a significant part of that time, I was chasing a problem that felt just slightly out of reach. Like I could see exactly what we needed, but we couldn't quite get there. And this problem was metadata, specifically How do you take a large distributed enterprise with content being created by hundreds of people in dozens of places and make sure that that content is accurately tagged, consistently organized, and actually findable? So if you've ever lived that problem, you know it doesn't sound glamorous, but it matters enormously because metadata is the invisible infrastructure that determines whether your knowledge management works, whether your analytics tell the truth, and whether your users can find what they're looking for. Next slide. Now, we had Synaptica in our digital stack for nearly a decade, but it wasn't until around 2017 that we got serious about building an enterprise-wide taxonomy that was genuinely useful. Now, the initial push was about reporting and analytics, getting consistent, reliable data. Then it evolved into something bigger, knowledge management, which included content findability, connecting systems across the enterprise. We made real investments, we built out a taxonomy, and then we built infrastructure to connect it all to our systems. But there were limits. Getting to that next level, a full thesaurus, maybe even an ontology someday, remained out of reach. And even the taxonomy work we had done came with a hidden problem that we didn't fully appreciate yet. Applying that taxonomy to content, actually tagging things accurately and consistently turned out to be the hardest part. When content creation is distributed across a large enterprise, self-tagging doesn't scale. Some people overtag, others undertag, many tag inaccurately. The result is inconsistent metadata across the board, and that inconsistency quietly undermines everything that you're trying to build on top of it. We spent a lot of 2019 focused on this. We brought in consultants. We even co-built a metadata tool with one of our data vendors. Smart people, really good intentions, but nothing we tried worked well enough for our content use cases within a budget that made sense. Next slide. So fast forward to 2024, getting the right content metadata had become a strategic imperative, not just a nice to have, but something that leadership was actually paying close attention to. So this time we invested in manual tagging resources, real people doing real work, applying tags by hand. And for a moment, it felt like we were making some progress. But then we noticed something pretty unsettling. Our taxonomy, which had gone through years of rigorous governance, had quietly drifted away from the actual language, the actual concepts of our content. The topics had evolved. The vocabulary of our technology domain had shifted. New terms had emerged that were important to our business, and the taxonomy in many places hadn't kept up. Now, this is a subtle thing that I think a lot of taxonomy practitioners understand intuitively, but struggle to articulate to your stakeholders. A taxonomy is a living thing. It has to breathe and adapt alongside the content it serves. When that stops happening, even a well-governed taxonomy starts to fail silently. So there we were. Manual tagging wasn't going to save us if the taxonomy itself needed to be updated. And we really had no efficient way to find these gaps. That's when we reached out to Dave Clark at Squirro. Next slide. Now, we weren't going in starry-eyed. We'd been around problems like this for years. We had tried other vendors. We had seen tools that looked promising and then fell short when they met our real-world content. So when Dave and Panos proposed a 4-week trial, we were hopeful, but to be honest with you, we were also prepared to walk away if it didn't deliver. Well, I'll say that it exceeded our expectations. The Squirrel toolset did something I genuinely had not seen done well before. It crawled our content and extracted the terms that were actually living in it, the language our subject matter experts and authors were using, and surfaced the gaps between that vocabulary and our existing taxonomy. But it didn't stop there. It auto-generated definitions for those new terms that were actually grounded in the nuances of our business, not generic dictionary definitions. And then it actually pushed those terms into our graphite taxonomy and ontology management system, ready to be modeled into our existing enterprise taxonomy. Next slide. So I remember the moment I saw this working and thinking, this is it. After years of looking, this was the first time I saw something that could actually solve the problem. Not a workaround, not a partial answer, a real solution. And for me, it was a light at the end of a very long tunnel. Next slide. So once the trial wrapped, we started thinking bigger. Now, the return on investment was clear, even at our initial content scope. But then someone in the room asked a question that stopped us all. What if we had had this 5 years ago? And to give you a little more context, 5 years earlier, we had acquired another pretty large company, and we ingested a massive set of marketing and technical content into our publishing systems and digital experiences. It was a multi-year effort, 3 years, millions of dollars invested, and the results were marginal at best, even after two go-arounds with this project. With what we knew Squirro could do, we estimated that having this tool during that integration would have produced better results in 6 months and saved us somewhere in the neighborhood of $4 million. So let that land a moment. $4 million. 3 years of work reduced to 6 months. And that's just one acquisition, one content integration, one chapter of our story. What does that mean for knowledge management teams' credibility with leadership? What does it mean for the ROI on 20 years of taxonomy creation? What does it open up for the GenAI initiatives that are downstream, waiting for that clean, well-tagged content to actually work properly? So the numbers matter, but so does what's behind those numbers. The human effort, the expertise, the years of work that a tool like this can finally make count. So I want to close with something I wish someone had said to me earlier. These types of solutions don't implement themselves. The tools are genuinely powerful, but you have to bring your IT organization in early, not after you've fallen in love with it. Early. If you don't, you'll spend months managing an obstacle that was entirely avoidable. And I learned that the hard way. The early days of AI capabilities coming into companies. So the metadata problem is solvable. The taxonomy drift problem is solvable. The content findability problem upstream of your Gen AI strategy is solvable. When you find the right path, it changes what you see, how you see the work and the possibilities entirely. So back to you, Jan.
All right, so thank you, Melinda, for demonstrating that the metadata problems, they are solvable with automated term extraction to allow to ensure that taxonomies evolve with the content, with all the downstream benefits that you mentioned for knowledge management, Gen AI, analytics, and so on. So next, let's turn to the engineering underneath, and Panos will take us one layer down into the scaffolding that connects your existing taxonomy, your unstructured content, and the LLM. And he'll cover how to serialize a taxonomy for an LLM, how to structure prompts for candidate extraction, and crucially, how to build a loop where your taxonomy team always stays in the driver's seat. So Panos, please take it away.
Thank you, Jan. So, with the emerge of LLMs, we quickly realized that we have now a very powerful tool in our hands, and we started building solutions in order to build the gap, to bridge the gap between taxonomies and content, solutions that we thought were unimaginable before the LLMs with traditional NLP and machine learning solutions. These solutions are meant either to leverage the taxonomies in order to enrich the content, or vice versa, leverage content and documents and enterprise corpora in order to maintain and extend the taxonomies. The set of these solutions, we call it CIS, Classification and Information Extraction System. And I'm going to present here today the key functionalities that CIS has to offer. Next slide, please. So, as Melinda mentioned earlier, a taxonomy is a living organism, and those of you that have worked with taxonomies and ontologies understand that this is a continuous effort to maintain taxonomies, test their coverage, extend them, and typically, what a taxonomist would do is go through documents, read them, have a highlighting marker, and identify new concepts, new entities, new things that could potentially be added back into the taxonomy. In this solution that we call candidate concept extraction, we do that automatically using LLMs. So what is going on basically is that an LLM takes a look at your taxonomy, then goes through a set of documents that you provide and comes up with extractions with new concepts that are candidates. And as you can see in the picture, on the left, there is a big list of candidate concepts. They were extracted from documents. And we have recorded that for example, this agritourism concept has been mentioned 3 times somewhere in the documents. The system itself recommends that we place this agritourism concept under agribusiness development, and at the same time, it has filled in all the fields for us, like labels, synonyms, and definitions that are grounded in the provided context in what was mentioned in the document rather than generic LLM knowledge. Then a taxonomist, a human taxonomist, would need to check these extracted concepts and decide which ones are suitable in order to be added to the main taxonomy. Next one, please, Jan. So the first function was about finding concepts in documents. The second one is about locating facts. And this is facts are in a form, in an ontology and a taxonomy. These are relationships among things. So in the hypothetical scenario where we have a food ingredient taxonomy, we would be interested in finding what, for example, types of oils and fats are used to cook what types of vegetables. So we have two high-level things, oils and fats, and vegetables, and then we want to find out how their children associate with each other, not based on generic knowledge again, but according to what documents we provide. In this case, that would be like a cookbook or something. So the facts that we extract from the content are things like, in this relatable example, is carrots are cooked with butter. And this is, on the one hand, an association between these concepts, and on the other hand, we know which cookbook and where exactly mentions this kind of facts. So if you look at on that way, we have tagged the document using facts rather than concepts. Next one, please, Jan. All right, so this far we saw how we exploit what's in our documents, what's in our corpus in order to maintain and extend our taxonomies. Now we're going to see the other side. The first functionality is semantic tagging, and this is about going through documents and finding each and every concept of our taxonomy that is mentioned somewhere. And this this used to be implemented traditionally with machine learning and NLP, and that would mean string matching in one form or another. But as you can see here, this tagging, because it uses an LLM, it takes into consideration the semantics and the context of the document and what the concept itself means in order to find the concept mentioned in the document. So in this example, you can see that the phrase budgeting and planning processes has been tagged as concept, budget preparation, and management techniques. Nothing matches as a string, but the concept, definition, and synonyms and semantics from the taxonomy um, all chipped in into this decision to make this tag. And next one, Jan. All right. So the previous one was about finding all the concepts in our document and highlight those and tag them. But then we have the need to perform what we call aboutness extraction. It's about finding the very few concepts that characterize the content of a whole document, and that can be served using the taxonomy. And here you can see a small example. There's a tiny taxonomy of computer science and a very small piece of text that mentions machine learning and deep learning. The previous step of semantic tagging would have picked those terms up and say it's deep learning and machine learning as concepts, but we can infer that the document is about artificial intelligence, which is their lowest common ancestor, uh, or we can say it's about computer science, which is their highest common ancestor, or we can be flexible. And one algorithm that we are using here is that the place within the document is very important into identifying the aboutness. So you would see you can actually configure that an abstract or an executive summary in a document is more important to define the aboutness of the document. Next one, please. So are we trying to replace taxonomies here? Absolutely not. We are building for taxonomies. We are building tools that will make their life easier, and the taxonomist is crucial in this whole process in order to review the extractions and approve any additions to the taxonomy and ensure highest quality for the taxonomy and the content itself. Next slide, please. So the functionality that I mentioned and I presented this far is something that you can try at home actually. You can spin up an LLM client like ChatGPT and try things yourself. We do that at scale with huge corpora and very large taxonomies, but this is something you can try. And in order to get these results, we need to feed three things into the LLM. The first one is the taxonomy, the second is the content or the document, and the third one is the prompt, which is the instructions of what it needs to do. And then we get the results. I'll go through this step by step in order to explain a few things. Please, Jan, let's move. All right, so first let's see how we can decide which part of the taxonomy we will feed to the LLM. And we have a few options here. One is we give the whole taxonomy, or we select a branch or more than one branches of the taxonomy. We can isolate one or more schemes, concept schemes, or one or more collections. And we also need to provide as much of semantics as we can so the LLM can understand what the concept is about. So we usually prefer to give the labels and the synonyms, and if there are any Scots definitions, we also pass them on to the LLM. In order to make this decision about which part of the taxonomy we need to feed, um, we need to consider factors like the size of the taxonomy, how many concepts we have, and whether the semantics that we provide are adequate. Next slide. Thank you. So once we have decided which part of the taxonomy to feed to the LLM, we also need to find the optimal format to serialize this taxonomy and give it to the LLM. And our recommendation is to use established formats like JSON, Turtle, Markdown, and we have found that the most condensed format for this use case is Markdown. It's very efficient. It doesn't have any excessive characters or unnecessary formatting. So you can see an example here how taxonomy hierarchy can be represented as a Markdown list, which has indentations based on the levels of concepts. Next, please, Jan. All right. We have now provided the taxonomy to the LLM. Now we need to give the content so it can so that the LLM can go through that. And again, we need to decide whether we will provide the whole document at once, whether we will process one page at once or a batch of pages, or we can even break the text into text chunks, meaningful sections, and process these at once. At small scale, these decisions are not super important, but at large scale, thousands or millions of documents and huge documents, these are engineering decisions that need to be made to have an efficient system. Um, Next one. So finally, we need to define the prompt. We have provided our material to the LLM, and now we need to tell it what to do. And it's setting a task about extracting candidate concepts, finding named entities, identify relationships, do tagging or abundance extraction. The flexible thing and very nice thing is that this is natural language, and if you know how to structure this, you get easily you can configure the system very easily and affect its functionality. So let's go to the next slide where I give a few more details. Some good practices that we like to follow is first off, assign a persona to the LLM. Some models lately do not need that, but some others do need that to understand what you're asking it to do. So you start by setting the scene. You are an expert taxonomist, a content create annotator, so act like one. And we need to provide the instructions in a certain order. We describe what resources we provide. So I'm giving you a branch of the taxonomy. I'm giving you a page of my document, and I want you to study that, understand that, and then I want you to do A, B, C, any task that we want you to do. And finally, we need also to define the format that the LLM will give us the results back. So it could be a JSON structure and say, give me every tag in this structure, and then our system will take it and process it down the road. Next, Jan. So a quick summary of the key challenges that you might face when you try all these at scale again. The LLMs tend to overgenerate and produce irrelevant results, and you need to limit that somehow. The LLMs are not good at being creative and validating their output at the same time. So we split that into two steps. The first one is generate, the second one is validate. And second, which is very important, is you always need to factor in the prompt size because prompts use tokens and tokens mean cost. So any way to reduce token usage means directly a monetary benefit for the user. So we discussed how we process a few pieces of the taxonomy, a few pieces of the corpus, and how we can batch things in order to be more efficient financially. Next,
Okay, excellent.
that
Thank you
was
so much,
all.
Panos. So now basically we've seen the real world operational pain and the direct payoff from Melinda. And We've also looked at the architecture and the prompt structures used to overcome these challenges from Panos. Next, we're good on time, so we can go through this carefully. We want to bring both viewpoints together. So let's take a look at this through the lens, for example, of a chief information officer or a head of AI who needs to fund, govern, and justify these initiatives to the board. And we'll do that in our fireside discussion. And to start it off, I'd like to start by addressing a common misconception. So very often we talk about closing the classification gap as if tagging data was the ultimate finish line. Of course, it isn't. It's simply the baseline precondition for everything that happens downstream. Panos, if we start with you, when an enterprise actually deploys a clean, connected, automated taxonomy across their unstructured data repositories, what business capabilities open up that were basically impossible before?
Yeah, so having a curated taxonomy that is maintained actively and extended and has great coverage over your content means that you have a foundational structure that will be the bottom layer of your organization to be data-centric, knowledge-centric, and build on top of that applications and systems that will help being AI ready and help the people access knowledge more directly.
Okay, and Melinda, from your seat as a practitioner, what's the cultural and operational difference in the day-to-day business when this works seamlessly versus the legacy status quo that you were also very familiar with?
Yeah, great question. When tagging is broken, the hidden cost isn't in the metadata, it's in the human behavior that forms around the gap. So, for example, people stop trusting search, stop trusting the systems, and they develop workarounds. And those workarounds can include personal file folders, tribal knowledge, Slack messages to the one person who knows where to find things. Those workarounds become the de facto knowledge management system, which means your actual system is essentially ornamental. When it works, something quieter happens. The friction disappears. So analysts stop prefacing every report with a disclaimer about data quality. Leaders stop asking, "Can we trust this?" before acting on what they're seeing. So the operational shift I noticed most was in governance. So unreliable tagging makes governance reactive. You're always chasing drift, always cleaning something up. And a reliable classification layer makes it proactive. You're steering rather than firefighting. And that's when the downstream value unlocks. The analytics, the personalization, the GenAI applications that are waiting again for clean, structured content actually work. So the baseline isn't the finish line, but without it, nothing downstream runs correctly.
Yeah, that makes a lot of sense. Yeah. Okay, and one of the quickest ways to kill momentum in an AI or taxonomy initiative is, of course, to try to clean up 20 years of technical debt all at once, right? So, Panos, realistically, what would be the smallest, most credible first project an enterprise could scope to definitively prove that the Squirrel classifier, in this case, delivers clear value without disrupting core operations?
Well, as in many cases, what's applicable here is the start small and dream big. These solutions are quickly showing their return on investment, and they will show you the added value immediately. But you cannot boil the ocean at once. You need to start small, have some taxonomists, some engineers in place, and you will quickly grow your taxonomies and your systems.
Hmm.
Yeah.
And, and Melinda, you've been the customer on the other side of this table. So knowing what you know now, if you were scoping a first phase project tomorrow, like what would you do
Mhm.
differently?
Well, first I would say that scoping a first project isn't just a technical decision, it can also be a political one.
Mhm.
So if I were doing this again, the first thing I do differently is pick a content set that already has a champion. Not necessarily the largest, not necessarily the most strategic, but find the business owner who's already frustrated with findability or data quality and make them your partner. When the trial works, they become your internal advocate, and that advocacy is worth more than any slide you'll build for leadership. And second, I can't say this enough, bring IT into the room before you fall in love with a solution. If your IT organization feels like they're being handed something instead of building something with you, you can spend months, on conversations that really should have only taken weeks. And then third, document the before state obsessively. Error rates, missing tags, how long it takes to find a specific piece of content. And then when you want to expand, you'll need to show that delta. The ROI story only lands if you captured what was broken actually looked like. So smart, start small, start with a believer, measure everything.
All right, thank you. Melinda, this one's still for you though. For decades, taxonomist roles have been treated kind of as invisible infrastructure, highly necessary, often underfunded, misunderstood by leadership. And how does
Mhm.
this role change now that LLMs can do much of the grunt work of mass extraction and classification in minutes? Is the taxonomist's job, is it getting smaller, is it bigger, or fundamentally different?
Yeah, that's a great question. For most of my career, the taxonomist time was consumed by the work that machines should have really been doing all along. Manual extraction, hunting for those gaps, reconciling vocabularies across systems. That work wasn't necessarily intellectually interesting. But it was very necessary. And there's so much of it that the more strategic thinking rarely got the attention it deserved. What changes now is where the expertise actually lands. So the taxonomist job becomes less about populating a structure and more about governing one. So deciding what gets modeled and why, evaluating what the machine surfaced and applying judgment about what actually belongs in the enterprise vocabulary. Connecting taxonomy decisions to business outcomes in language that leadership can act on. So this last part is new and it's quite significant because when you can show leadership that taxonomy drift was costing you 3 years and $4 million on a single integration, the conversation changes. The taxonomist stops being invisible infrastructure and starts being a strategic function. So I would say that in the end, the grunt work is going away, but the judgment work, the curation, the governance, the business alignment, that is not going away. And it's finally getting the space it's always deserved and needs to be successful.
All right, thanks. And Panos, to wrap up this part of the webinar, what do the most effective, highest performing taxonomy and AI data teams look like now in 2026? How are they structured? Are there any patterns that you see?
Um, of course, it depends on the business of its organization. What usually happens is you need data engineers, you need taxonomists, ontologies, which go under the umbrella of knowledge engineering, and then you need software engineers in order to be covered and future-proof into building applications with AI.
Right. Thank you. Okay. So this wraps up the fireside chat. If you had to take only three strategic pillars away from today's session, here is a proposal. First of all, I think we stop treating your taxonomy as a legacy maintenance cost. So it really is your single most valuable data asset, and your downstream GenAI investments, they really depend on it. So that's point one. Secondly, the classification gap is basically solved when you can combine the processing speed of an LLM with the deterministic rules of a graph solution. That's where the Squirro classifier, it's what it delivers. And third, it isn't just a technical project, it's an organizational one, as Melinda pointed out. So really get your IT teams, your taxonomy leads, AI sponsors aligned on issues like data governance and so on before you write the next pilot check. Mm. So now we've seen what closing the classification gap can unlock for the taxonomist day-to-day work, for the AI initiatives downstream, and for the strategic position that your organization will be in 18 months down the line, for example. But of course, as Panos mentioned, every taxonomy is different, every content estate is different, and every organization is, of course, at a different entry point on this same journey. So our goal is really to help you cut through the noise and scope a first project that actually proves the value, something that's bounded, measurable, and with the right stakeholders in the room from day one. Whether you spent 20 years curating an enterprise taxonomy or you're starting at a blank page, we can walk you through what the first 4 to 8 weeks could look like for your team, what it would take to integrate with your existing systems, and what success would look like at the end of it. So click on the link in this presentation or scan the QR code, reach out to us directly. We'd really love to hear what you're working on and would love to help you scope the next step. Okay, so this brings us right into the Q&A section of the webinar. Thank you to everyone who's already submitted questions. We, of course, want to respect your time. We'll try and hit as many of these as possible. So I would say we jump right in. Panos, Melinda, I think you can see the questions as well. If you see something that catches your attention, just feel free to
Uh,
respond.
I can take the first one, Jan. One that reads, when dealing with a massive enterprise taxonomy that has tens of thousands of terms in deep hierarchical structure, how does Squirro manage to fit that into an LLM without hitting context limits and blowing past token budgets? That's a great question that I partially covered through my presentation. These are engineering decisions that need to be made about which parts of the taxonomy you want to work at a single time. If you have thousands of concepts, it's quite difficult for the LLM to comprehend the semantics of your taxonomy and it will lose focus quite fast. So you need to be smart and proactive and work on smaller pieces of that taxonomy. Same goes for the documents and content. You cannot put 100, 200 page document and expect the LLM to do a very good job. But if you split that down into pages or sections, then it will be much better.
Okay, thank you.
All right, I can take the second one. In Melinda's presentation, she showed the overlap of the old existing taxonomy terms with some outdated terms, as well as the new language terms identified that needed to be added. Is there any risk or concern with keeping the old outdated terms in the taxonomy? Do you leave them in or remove them? And what criteria do you use to decide if a term is no longer needed? Sometimes the old becomes the new again. Yes. So this is a perfect example where the human in the loop taxonomist is still a critical piece of this whole picture. And it's also one of the things I did not touch on was how extraction helps you build a thesaurus. So utilizing, you have primary concepts and then you have alternative labels. Some of those old terms may be still used by some of either your internal or your external customer searchers for information. And if you move some of those older terms to alternative labels as part of your thesaurus, that is one way you can treat them if there is a need. But the risk of leaving old terms as primary terms is that you may have people or machines that are still utilizing those old terms to tag. And that becomes a problem if you want the newer terms used in those as tagging for those new terms. So it depends. And that's where you need someone to help you understand what the best choice is.
Okay. Hmm.
So
Do you see
can I
one?
pick the
Yeah.
next one?
Yeah. Sure. Yeah.
So there is an ongoing conversation of sorts with John in the chat. The first question was how many taxonomies might appear in a company and whether we propose one taxonomy for an entire enterprise. My response was I advocate for modularity. That means one single taxonomy for an entire organization sounds horrifying for me as as a knowledge engineer. Um, and the follow-up question from John, which I'm going to respond, is: given a preference for modularity, how do you ensure that feeding a taxonomy and a set of documents to an LLM doesn't result in taxonomic collisions with previous taxonomies? So I'm not sure if I get correctly the term collisions here, but in general, taxonomies are assets that are versioned like many other things in engineering, and the follow-up or the results of using a taxonomy needs to also be versioned. If you evolve your taxonomy or you have you drift your semantics somehow, you extend your taxonomy, you need to redo a new version of your classifications, your taggings, or whatever, in order to be sure you don't have any gaps semantically.
Okay. I see one more question that we have not addressed yet in the list. I think this one's probably for you, Melinda.
Yes, related to bringing your IT into the conversation, what if you struggle with getting your IT to understand the need, value, purpose of a TOMS tool for taxonomy and ontology? That's a great question. And I will say that I spent a lot of my time when I was working at the large technology company educating people about the need for taxonomy, what it could provide, how it could save people time and money. And this was not only from the business perspective, but from the IT perspective as well. So it's education, education, education continuously, and also then refreshing that education as things change in the environment. This is a fast changing environment, as we all know. But I think the thing that really resonated with people was this will save you time and this will save you money. And if you can show that value, you will get buy-in. So I hope that answered your question.
All right, excellent. Thank you. Yeah. Panos, more on modularity.
Yes, so the question is, in a modular taxonomy ecosystem, how does a knowledge engineer know that they are choosing the best one? Do they consult with taxonomists in these cases? So, yeah, my ideal team, as we discussed earlier, is you have knowledge engineers and taxonomist ontologists in the same team. And what I forgot to mention back then is your SMEs, your subject matter experts or domain experts. These are people in whose heads the corporate, the organizational knowledge lives. So you're in constant back and forth with them to understand what are the right choices and the right semantics for things in your taxonomies and ontologies. So all these categories of people need to work closely together to achieve the best results. Of course, it all depends on the line of business and the use cases and whatever is the final purpose.
Yeah, I'll add on. I agree with what Panos mentioned. It's definitely a multidisciplinary effort. But you always have to ask yourself, what is that end state? What are you trying to get to? Is it a digital experience and you're needing to surface something in a certain way because you have customers looking or searching a certain way? Or is there some sort of an analytics dashboard that's being built, and what are those attributes that are needed in that dashboard, and what are the concepts that you need to be able to filter the data on? So it's so important to look at what is that end state what am I trying to do in the end? And that helps guide what taxonomies you use and what form they take as well.
Excellent. Yeah. Um, yeah, Panos, do you want to take that question by John O'Gorman? There's one more
Yes, yes.
follow-up.
So, by collisions, I meant semantic overlap. For example, how would terms in an accounting taxonomy and terms in a payroll taxonomy work together? Um, so, I assume that in that example, these two taxonomies have been developed by different people, and these can be aligned in several ways. The simplest one is put these people in the same room and create mappings between the two. The knowledge graph world, the ontologies, RDF are very good at that. It lets you associate things with each other and define what kind of associations you have. So there are several ways to overcome this difficulty, but I'm pretty sure it's doable. And in general, when I say modularity, I would need a taxonomy or a set of concept schemes in a taxonomy for finances, another one for products, another for policies. These can go through many departments of an organization. Doesn't mean every department needs their own taxonomy.
Great. Okay. So I think we've covered all the questions. Fantastic. Uh, with that, I guess that brings us to the end of our session today. I'd like to extend a huge thank you to Melinda for sharing her experience so candidly, to Panos for walking us through the architecture and really the nitty-gritty of how to actually solve these challenges. And of course, thank you to all of you for the questions and for sticking with us until the very end. As a quick reminder, you'll receive the full deck and a link to the recording in your inbox in the coming days. And if you are curious about what closing the classification gap actually would look like for your organization, then please reach out. We'd really love to set up a classifier-focused assessment, walk you through what a first project could look like with your team. So, finally, last words, this webinar is a part of an ongoing series where we look at real-world enterprise AI in production. So please keep an eye out for upcoming sessions. With that, thank you again for joining us and have a very productive rest of the week. Goodbye.
Bye.
Thank you. Bye.